All right, you guys, this is 2.7, which is a lot like 2.6a, but now dealing with absolute value graphs. So the parent function for absolute value always has the bars with just the x inside. So f of x equals the absolute value of x. What you see here, the green, is this little point right here, is your vertex. And then the red is your axis of symmetry. Okay, and we will do AOS for that a lot. So if you see AOS, axis of symmetry, okay, but let me just show you what happens with this parent function. Typically we plug in -2, -1, 0, 1, and 2. Doesn't have to be in that order. 0, 1, 2, -1, -2, that's fine. But it's just good to have positives and negatives, especially when dealing with absolute value. So if I plug in the absolute value of -2, so I'm just plugging it into this, right? If I do that, I get 2. If I plug in the absolute value of -1, I get 1. If I plug in the absolute value of 0, I get 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So you can see 0, 0, 1, 1, 2, 2, -1, 1, -2, 2 gives you this graph. Okay, so that's your parent function for absolute value. It is always a V shape. Okay, and then the translations are a lot like what we just did in 2.6a. It's going to look like this. Absolute value of x plus k is going to bring it up, and then minus k is going to bring it down. Okay, and then the left to right, again, is the one that's a little funky. So these are the same as what you would expect them to be. These are the opposite of what you would expect them to be. Normally, if we do minus, we think, oh, go to the left. Those are the negatives, right? If we go this way on the graph, that's where it's usually negative. Well, because we're taking the absolute value and then subtracting with it, it ends up being a shift to the right, okay? So just keep in mind when there's a minus, you're shifting to the right. If it's inside the bars, right? The minus is inside the bars, you go to the right. If the plus is inside the bars, then you're going to the left, okay? So the outside stuff, when it's outside of the bars, it's the same as you're used to. When it's inside, excuse me, the absolute value bars, it's the opposite of what you're used to. Okay, and then with the absolute value ones, we're also going to do reflections. We skipped that with the other ones. That's what 2.6b was, and we have to take some things out this year, and that's one of the things we decided to take out. You can thank us for that later because that's not everyone's favorite lesson. But what you're doing here is if you see y equals the negative absolute value of x, so the negatives on the outside, you are reflecting over the x-axis. So in other words, if I have this, then the negative becomes this. It flips over your x-axis. Let's draw it in a different color so you know which ones go together. Okay. Whereas if y equals the absolute value of negative x, that reflects over the y-axis, so nothing changes for your parent function. If I started with this graph, and I reflect, this one right here, reflected over the y-axis becomes this ray, and this ray, reflected over the y-axis, becomes that ray, so it looks identical, okay? So just keep in mind, if the negative is inside, you're reflecting over the y-axis. If it's on the outside, you're reflecting over the x-axis, okay? Okay, and then last thing before we get into how we graph some of these is how a absolute value graph will stretch. So notice the parent function doesn't have this a in it. When we put that a out in front, that is like your slope, right? That's like your m in a problem. So you can kind of think of this as your rise over run, if that helps you, rise over run. So it's a positive or negative a over 1 because it's a whole number. Okay, so plus 5 means you're going up 5 over 1. If it's a negative 5, you're going down 5 over 1. And then it's just a reflection typically from there. So let me show you what some of these graphs will look like, and we'll see how you do. So example 1 here, it says graph the translation. So the plus is outside of our absolute value. So for that one, we are going up 3, right? So 1, 2, 3. If you look back to your setup here, that's this one. It shifts up. So up 3. And then there's nothing out in front, so you're just going up 1 over 1. Up 1 over 1, just following that slope of the parent function. So your graph would look like that. Always a V when there's absolute value. Okay. Okay, next one, x plus 3. Remember, when it's inside like this, we go opposite of what we would expect. So normally it feels like we should go 1, 2, 3 to the right. We don't. We want to go 3 to the left on this problem. So 1, 2, 3. And again, there's nothing out in front right now. So we're just going up 1 over 1, up 1 over 1, and this is your graph. Okay. Okay, now it gets a little bit fancier because now there's 2 of them. Maybe pause me real quick. Ask yourself, where am I going to move for that? And then unpause me, and I will tell you where you're going to move for that. For this one, let's just start here. Outside, these are the ones that are the same as what we're used to, right? So this one, you are going down 4. Okay, this one is going to be the opposite of what you would expect. So this is left and right. It's a -1, so you're actually going to go right 1. Okay, so if I go right 1 and down 4, I would end up here. That is my vertex. Okay, again, there's nothing out in front, so we just go up 1 over 1. Imagine your slope is 1 if there's nothing there. Okay, so that looks like that. This next one, we have a -1 here. So again, we're going down 1. And then the plus 3 inside, remember, opposite of what you would expect. Inside is always opposite. Outside is the same. Inside of the absolute value bars, we're going plus 3. So that means we are actually going to the left 3. So left 3, 1, 2, 3, down 1 would put your vertex right here. And then again, nothing is in front of there. So up 1 over 1, up 1 over 1, you get that graph. Okay. All right. Now you'll see when there's something in front of the absolute value, what you're going to do with that. So notice there's nothing going on here, and there's nothing else going on inside of the absolute value. So there's no move up and down. There's no move left and right. That means that's essentially your parent function, just with a different slope. Okay, the 3 is the only thing that's different. So our vertex is still going to be 0, 0 on this one. And then we take that 3 and we treat it like a slope. Up 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Notice what happens. It squeezes skinnier. Okay, and I want you to see what happens on this next one. Same idea. There's no left and right, no up and down. There's nothing else back here. But we have this slope of -1/2. So our vertex is still at 0, 0. But now treat this like a slope. We're going down 1 and over 2. Down 1 over 2. Down 1 over 2. I missed that. Down 1 over 2. Down 1 over 2. It looks like this. Okay, so there's 2 things I want you to see here. First of all, when it was positive, it opened up. When it was negative, it opened down. Okay, so that's how it will always work. Positive opens up, negative opens down. But then also look at this. This number is a 3. This number is a 1/2. The 3, the bigger the number, the skinnier it gets. The smaller the number, so move into a fraction, the wider it gets. Okay, so that feels kind of backwards too, I feel like, because a bigger number, you would think it opens bigger. But the bigger the number, the skinnier it's going to get. So if it was a 5, right, it would be even more steep. If it was a 1/4, it would be even more wide. So the smaller the fraction, the wider it gets, the bigger the number, the skinnier your compression is. Okay? Okay, so all that to say, here is the general form for these absolute value problems. Okay, we have A, which we're going to treat like a slope. Okay, this H value is going to be our H of our vertex, our X value of our vertex, and then the K is going to be the Y value of our vertex. And then our axis of symmetry is always X equals whatever that H value was. Whatever this X is of your vertex, that's going to be the vertical line, the axis of symmetry. Okay, so let's talk through that. You have, for this first one, your A is going to be 2. Okay, your H, and be careful here, it's tempting to say that H is -3, but it's not. The general form is subtraction. So this is your thing, your number. So if it's a minus here, my X value, my H value of my vertex is just 3, not -3. Okay, again, it's opposite of what it looks like inside. So if it looks like a -3, it's actually a +3. This one is what it looks like. So that's a +4. So then my axis of symmetry is X equals H. Well, H is 3. So X equals 3 is my axis of symmetry. And if you were to graph this, you would see that. If we plot the point 3, 4, 1, 2, 3, 1, 2, 3, 4, right here, okay, my axis of symmetry has to go through my vertex. So my axis of symmetry is this line right here. So I want to see that. I want to see your axis of symmetry drawn in. I want to see your vertex, okay? And then don't forget to do your slope. So from here, we are going to go up 2 over 1, up to the other way 1, and make our V. Okay, so there's a lot going on there. Just take your time, do it one piece at a time. Okay, so the second one, try this one on your own real quick. Pause me and try this on your own, and then unpause, and we will do this. A is -3. Okay, this is your H. This is your K. Like I said before, inside it's opposite of what it looks like. So if it's +4, that's because we're doing minus a -4. Okay, the original form is subtraction. Up here, it's subtraction. So if it looks like addition, it's because we subtracted a negative, right? So that's a -4. This one stays put, a -1. So my vertex is -4, -1, right here, which means my axis of symmetry is the line X equals -4. And just a reminder here, an axis of symmetry is always X equals a number. You cannot say my axis of symmetry is -4. You need to say it's X equals -4 because it's a line, okay? So we draw that line in. It's always going to be a vertical line for an axis of symmetry here. So we do that. We have our vertex, we have our axis of symmetry. Now we just need to do our -3. So negative means it's going to open down, right? 1, 2, 3 down over 1. And then start back at the vertex, go 1, 2, 3 down and over 1. And we get that graph. Okay. Okay, now this one is a little tricky because now you have all the pieces and you have to figure out what the equation is. So let's take a look. We know general form. Oh, there's an A there that doesn't belong there, sorry. So the general form, right, we say y equals A times the absolute value of X minus H plus K. So we're just trying to plug in a number for A, a number for H, a number for K from this setup. So here it is. First of all, your vertex is right here. So I would write that out. My vertex is 1, 2, 3, 1, 2, 3, 4. My vertex is 3, 4, okay? Then figure out what is your A value. And your A is going from here to the next point you hit. So I would say it hits perfectly right here. So we're going down 2 over 1. So -2 over 1. You can just call that -2, right? And now we're just dropping it into our form. So y equals negative 2 times the absolute value of x minus 3. It's a positive 3, but we're always subtracting, plus 4. So that'll be your equation, okay? You try it. What do you do for letter B here? Okay, so we have our standard form again. It's not wanting me to zoom in. There we go. So if I take y equals a, absolute value x minus h plus k. Pause me if you haven't paused me already and try it on your own. Okay, notice our vertex is here. So negative 1, 2, 3, 4, 5. So our vertex is negative 1, negative 5. Okay, and then our A, if we're going from this point here to the next point that we hit perfectly, right? We don't hit here, we don't hit here. So we're going 1, 2, 3 up, 1, 2 over. So up 3 over 2 is an A of 3 halves. Okay, when we plug that in then, we get y equals 3 halves times the absolute value of x. Now be careful, x minus a negative 1 is x plus 1. Remember, it's always opposite of what it looks like it should be on the inside. On the outside, it's plus k, so it's plus a negative 5, which is just minus 5. And that will be your answer. Oh, love that lesson. Isn't that beautiful? God is so creative, right? It's awesome. And that is it for 2-7.